Welcome to my last YOLO I custom object detection tutorial from the YOLO series. After giving you a lot of explanations about YOLO, I decided to create something fun and interesting, which would be a Counter-Strike global offensive game aimbot. Well, actually, what is aimbot? And the idea is to create an enemy detector, aim at that enemy and shoot at it. The same idea we could use in real life for some kind of security system, for example, detect and recognize people around our private house, and if it's an unknown person, aim light at that person or turn some kind of alarm, or this can be butter or paint gun. Also, I thought that it would be fun to create a water gun robot that could aim to an approaching people and shoot the water. And you might ask, why water actually? And to avoid the violence, of course, I would answer. Of course, this will be interesting, very interesting, and I'm interested if you would like to see something like that. And if you do you donate me some kind of money to do this kind of project? And well, of course, in the future. But I'm not talking about what we could do. Let's talk about what I did. So first, I took my YOLOv4 GitHub code, on which I was working half a year to make it easily understandable and usable. I created a lot of tutorials to explain every part of it. And actually, here is this code I'm talking about. And this is my personal computer specifications. And there at the end is a lot of tutorials where you can see my results, instructions, theory explained, and so on. That's quite a lot of tutorials. How to train model on Colab, custom model, how to detect with original weights, how to convert to TensorRT, how to use it on Raspberry, how to measure the precision, and so on. I made actually a lot of tutorials, and here is my results and comparison with YOLOv3 and YOLOv4 and so on. I even wrote a tracking model, so it's up to you if you need this or not. For this tutorial, I used a technique I explained in my previous tutorial, and this one, to generate a training data for my model to make it quite accurate while detecting enemies. So while using this technique, I don't need to label 1000 of images or so on. So I use this technique, and if you need, everything is posted on my text version tutorial. Just check the link on the description. So first, I would like to discuss instructions, how you can run this, for example, my model by yourself, then about results, and lastly, I will talk about code. So there will be 3 parts. So first, as I mentioned before, there's my specifications computer. I use a i7 CPU, Ubuntu operating system, CUDA 10.1, QDNN 7.6.5, TensorRT 6, TensorFlow GPU 2.3, and code was tested on Ubuntu and Windows 10. TensorRT is not supported officially on Windows 10, so there is a workaround for this. So actually, I began to telling you why I chose to use Ubuntu, but why not Windows? Well, actually, because it's much easier to run TensorRT on Ubuntu than Windows 10. And I actually did already a tutorial how to run this TensorRT. You can try to run it on Windows 10 with the following tutorial. And this is not the official way how to run TensorRT, so it might be tricky for you if you're new at this. So it's not recommended. It's better to buy better GPU probably, and then will run faster for you. And actually, you would need to run this by compiling everything by yourself according this weak instructions. Why I'm telling weak? Because I also tried it. I succeeded, but actually it took me a whole day to understand how to do this, and I don't think that I could do it again without these instructions and without diving into many errors. So actually, it's up to you if you would like to use it on Windows or Ubuntu, and it's your choice. First, the same way as in this tutorial, you must install TensorFlow, Python 3, CUDA, QDNN, and etc. packages to prepare the TensorFlow environment. Second, if you are on Windows, it's quite easy and obvious how to install Steam, but if you are on Linux, it's a little bit harder. So By myself, I tried at first use a standard way, well, how I googled it, and I tried it that way to simply use sudo to install and load Steam and so on, but I faced a lot of errors with CUDA and drivers compatibility. So I found a very easy way while using a Flatpak, and I used simply these commands installing the Steam, and I'll copy this one and I'll open the terminal to run my Steam actually. So while using Flatpak, there still might be errors while installing or running Steam, but you should solve them with Google Help actually quite easily and without facing many errors. And of course, if you are using a Linux, you already may be familiar with a task of solving problems. So you know what I mean. So actually, I go to my library. I'm not going to explain how to install Steam how to install Counter-Strike Go on the Steam. But when you have it already downloaded, we can download my GitHub repository. There it is. I will add the link on my text version tutorial. You can clone it or download as zip file. It doesn't matter. I already zipped my training model, which I put into the checkpoints folder here. And if you are on Windows, you can unzip it using 7-zip. If you are on Linux, there are two ways how to unzip this. So actually, where it is, you can use a P7-zip from following tutorial. I'll add all links on my text version tutorial. You can using this with zip with an interface. It's quite easy to use, or you can use following instructions. You need to install unzip unrar p7-zip full, install few packages, and here on my code in the zip location you can file Linux unzip files by script, which you can use to unzip simply these zip files, and you can actually use that model after that. Also, there is a requirements, and if you haven't installed these requirements yet, as I explained in my first tutorial, you should do this. And at first step, what I recommend is to try this tutorial. Try if TensorFlow works for you, if the detection works for you, if it's using GPU and so on, because on CPU it won't work. And I didn't even try to test it because it's very slow. Well, except if you have one of the newest GPUs. Now I can open my code. Here is the code, and my YOLOv4 configurations file is here. And actually, I'll begin with a simple detection without any TensorRT, but simply TensorFlow with input size of 460. We simply need to run it. You might change YOLO input size if you need better accuracy, but you will lose in frames per second. Now, when you have running the CSGO game in the background, we simply need to run the YOLO aimbot main script, and actually I will show everything for you in a moment. But first, if your mouse is flying around in game, open the game console and type raw input 0. This will disable raw game input, and you also need to change sensitivity or other minor settings. But if you are just watching this YouTube video, don't miss to check my text version tutorial, because I gave quite brief explanation how to change configurations, how to install, and so on, and gave all the links where you need to check everything what you need. So actually, I think that I can run the game and I'll show you the results, and this is the most interesting part. After showing the results, how my bot works, we'll move to the code explanation. That's not everything interested in it, but part of you might be interested. So let's wait for my game to run, and I'll open one of the maps and we'll see what I can do. I'm moving this to the left side of my monitor. I can minimize Steam actually. And okay, where's my code? YOLO aimbot main. So now actually I need to open the game, start the playing, and then we'll run this bot. And actually now I will show you, I'll begin with the simplest version, so it will be TensorFlow with 460 input, and I'll use custom workshop apps and harmless bots. So I will show you how everything works. And what I must tell you, that at first I will show you, you won't see any targets or whatever my bot is detecting, because it consumes time to show this, or actually I can run the game. Okay, and I'll a little bit change the code. So at first I will show you what my bot can see, and then I will simply comment this, because this consumes frames per second. It works slower when I am showing the screen. So actually I will be shooting terrorists on this quite interesting map. And for now I'll move it here, and here will come my another screen. Wait a moment, I'll just run it, save, okay. Invalid syntax, what's wrong here? So just give me a few seconds to start. So now it's waiting for window. It's my custom implementation. I will talk about this later. So I rebooted it, and I had an error in my code. So I fixed it, and now you'll see it should start in a moment, and a window should appear. Okay, as you can see, here's the window, the frames per second of detection, and I'm just gonna play a little, give it a. So as you can see, it's working with 11 frames per second. While recording it's a little bit slower, but without recording usually it's about 12% per second. And as you can see, I'm not moving mouse around here. I'm not tracking the bot by myself. I mean enemies. Everything is done by actually my script, and it's moving to the head, but because this quite low frames per second, as you can see, it don't have enough time to move to a head, because actually, as you can see, enemies are running around and they're not shooting at me. So it's a little bit hard for bot to track the head correctly, as you can see. So I have a solution here. So I will run another bot, and I'll run on TensorRT model which I generated. So let me just turn it off. Turn it off. I'm changing configurations. So here right now it will be not TensorRT, but not TensorFlow, but TensorRT, and here is my model actually, and let's run it now. TensorRT model loads a little bit slower, so it's not a problem. Let's give it a try, and after that it should be start detecting the same as before. So now should appear a window. It goes here, frames per second. As you can see, 23, 24. It's twice more than before. Actually, it's much slower because of recording, but on the website I'll post you my original results. So as you can see, it's much better for my bot. I'm not moving it around. It's shooting by itself. I'm just, when there is no enemy, I'm moving around the mouse for the left or right. Other tasks like shooting or tracking the head, it's doing by itself. but still, as you can see, with 20 frames per second, it's quite hard to catch them because they are quite running very fast around. Yeah, I'm right. Am I right? Yes, I'm right. And as you can see, the accuracy not the best because actually its input size is quite low, 460, but it doesn't matter. If you have a better GPU than I do, you should receive a much better results. And of course, also I'm having quite old CPU, so it's also performing a little bit slower because of that, but it doesn't matter. So as you can see, my prototype is working. It's quite fine, and let's move to some kind of more interesting map. And one more thing I would like to do is, yeah, but first let's move to another map. Let me close this. So I'll show you how I moved to this another map. Simply close. We should stop playing. Yes. And play CCGO, official workshop maps, a map. And now I'll use an easy bot. So it will be harder for me. And of course, deathmatch. And again, I'm in code using to target and shoot terrorists, and I will explain this later. So right now, let's keep it with counter terrorists. I move here, and now I'll move my window to the left, another screen, and I'll just start the script. So you will see everything, what I'm doing, and how my bot is actually detecting enemies. And after that, of course, I probably gonna turn off this visualization of detection screen, so you will see better frames per second, and of course the performance will increase of my model. So it should appear now. Okay. As you can see, I'm not shooting or targeting. Everything is done by the bot. Terrorist is dead. Okay. Everything does the bot. I'm not shooting here. And this is why I recommend to use a little bit higher model input. Actually, but everything depends from where you are actually. And right now I'm on small map, so it doesn't matter. I can move this. I can use this bot with quite small input. But if this is a larger map, it's quite hard to detect enemies which are far away from us. But actually, that's quite fun because quite high frames per second, quite nice accuracy, and as you can see, it's really nice. Doesn't it? Not me. Yeah, not me. So as you can see, that's quite interesting. Now let's try my another model. So I will turn it off, I mean, and I'll change the input size to 608. And also here I'll change. And right now I'm gonna not show you this kind of screen. I'll just move this to the left. Did not under what? Why it's here? Okay, doesn't matter. Let's run. And right now I'll move my window to here. And you see that it's a little bit different with higher frames per second, but for me, it's more interesting because the accuracy is better. And actually, right now, I again gonna give him some time to target enemies. No, that's bad weapon. I don't like it. So it started. And there should be about around 20 frames per second. And much better accuracy because of detection. As you can see, I'm not detecting my teammates. Lol, that's quite interesting. But mostly what I love is sniper because I can't target that fast as my bot does. Actually, as you can see, 2 headshots with... Damn! Everything is done by bot, not me. Keep this in mind. That's really fun, and I would like to see the results how better GPU would perform this kind of bot. Damn it, that can be a cheat actually. Look at it, how fast it works. Damn it. Only headshots. I don't know, you believe me or not that that's not me, but only a bot. Not me. So actually you see the results, that's quite interesting. I can move around a little bit closer to see how it would work. I don't want to die simply also. It didn't work right now. It started targeting, but it didn't. And now it was a bot. I'm just running around like an, I don't know, insane. Who's shooting at me? Damn it. Bot this. So that's quite fun, interesting, doesn't? But that's enough for now. I'm not here to show you how I'm playing with a bot. This is quite interesting. I will close this, and of course I don't need this game anymore. Also, I just wanted to show you what you just saw. And what I should say that I used only around 1500 images to train my aimbot model. Most of this training data I generated with the method I explained in my previous tutorial. To make it even more accurate, I recommend to use more than 10,000 images in different maps and so on. Then we would be sure that our model won't detect enemies wrong. Best to understand my results will be to watch my YouTube video. Anyway, as you can see, I run 3 different models. So what I could tell from my own results, at first I used a standard YOLO TensorFlow detection without TensorRT optimization. This is what you can get on Windows 10 with an 80 Ti GPU. But you have a newer GPU, but you can get better results if you have, of course. Then I converted my TensorFlow model to the TensorRT model with an input size of 460. And as you can see, as you saw, frames per second increased more than double. That's what I was talking about. Mostly I will use this model for small maps where our enemies come closer to us because it's not that accurate with small objects. And the last one was TensorRT in 8 model with an input size of 608. As you saw, frames per second is not that great, but I'm sure that accuracy is very high. I would like to have NVIDIA 3080 or even 3090 to see what I could get with it. So I'm sure that the latest generation video card could reach much better results. So even if my current results are not so bad, can you imagine what it would be with these new cards? And that's quite insane and interesting tutorial. And now, this is not the most interesting part. I will show you a little the code. And there is not a lot to talk about. So if you have experience in Python, it will be quite easy to understand the main script. For this tutorial, I wrote YOLO aimbot main py script, as you can see, and you can find it on GitHub. So first, this is specific for Linux. This one is get geometry window. Actually, when I start the game, I use this following command, which is used in Linux to find a window tab. So I use this tab to find if my game is opened or not. And if a game is opened, I try to find a geometry of that window, for example. And if my window is not opened here, I use another command to focus the view to my opened window, and again try to get this kind of parameters of geometry. And when I have a geometry, I have coordinates of my window, where is x, y, height and height, and I know what my specific parameters of what screen I should grab. And next I then move to my another window. I use a MSS library to grab a screen, and this one function creates a TensorFlow model I used here, and simply I grab a screen with specific commands, converting colors from 4 channels to 3 channels, simply sending this to detection or to my model, and it returns a completed image with detection list and bounding boxes. Here next I add a center of my aim sight. So there, as you can see before, it had a white circle at the center of screen. This was done with this command. So next, because I'm shooting at terrorists, I use here terrorist head and terrorist, and I give a priority to terrorist head. And as you can see, I sort the detection list, and I put the detections to the terrorist head list or terrorist list. And if I found some kind of heads of terrorists, I simply use this. Else, if I can see heads, I try to shoot the body if I see it. So simply here I move my mouse to the target by the difference of pixels for how far away is my white target on the screen from my enemy. So I calculate the difference, and simply I try to move a mouse there. And that's it. I do the same with terrorist, and I only click shoot when the distance difference is smaller than 12. So when my aim is closer to the head, not to waste my bullets. And actually that's it. Well, that's my whole bot script, what I should do. And what else to say? So here is simply a command to put frames per second. What you saw in a blue screen, here it was running. This is used to show my detections and so on. And that's it. This is the whole script, the whole magic where it begins. So the hardest job was to simply train a model, to detect it, to prepare everything, my environment, and so on. So that's it. As you can see, that was an amazing result. And I am quite happy with them. To the end, I should say that it was a really nice and interesting journey while creating this YOLO tutorial series for you, my friends. This tutorial is only one example of thousands where we can use object detection. If I would be having the latest generation video card, results would be even more impressive. This tutorial proves that using machine learning we can automate almost any game. We just need to have resources, time and knowledge for how to use that, how to adapt what we know, and that's it. You can download these projects files and use them at your own risk, of course, and I have them all here uploaded. Instructions on my website, so you can continue developing on it. You can even develop or reinforcement learning engine. I would be really impressed to see one, because by myself I don't have time for that, and of course it would require time, money, and of course a lot of stuff. I don't have this, and I believe that with NVIDIA 3090 GPU with 10,000 of training images, and if you know how you could optimize my code even more by improving grabbing screen, detection and post-processing times, you could achieve quite amazing results. This could be some kind of undetectable legit cheat. Let's say it's quietly. And as you can see, that was an amazing results. Anyway, thank you all for reading. Hope this tutorial was useful for you. Like this article, my YouTube video, and subscribe me on YouTube channel, and see you on the next time. I'm waiting for your comments, what you want to see next in the future from me. Thank you all for watching, and goodbye.